In the earlier video, we spoke about having polymorphic method parameter types can really allow us to add dynamically different types of objects into the array or collection. That's how we can create a polymorphic collection. Let's now think about if we want to get something out of the polymorphic collection, what kind of objects can we expect? So that will also make our return type polymorphic. That's something we want to speak about in this video. Right, that's why you can see the title here. We are trying to apply polymorphism in the context of method return types. Let's see exactly how that will go. It's not very difficult. You just have to watch out for the little details I point to you. Okay, we still use the same example class student management system, and we still have our students array where every element in the array has a static type students. And dynamically, it can be any descendant class of students. And we thought we spoke about how we can use the addStudents method. You can see the static parameter type is simply students, meaning that when we call this method here using arguments, the static type for the argument can just be any descendant class of student class over here, right? That's what we spoke about earlier. And what we want to introduce right now is a new method over here. And the new method is simply called getStudents with certain index over here. Let's just make for illustration. The index I over here, we can definitely check for its validity to see if it should be within the range of from 0 until ss.length -1, right? The array, the largest index for the array ss. We want to pay more attention to this return type over here, because this return type really restricts about what might be returned inside the method of implementation. And also for the caller of this particular getStudent method, what can they expect from the method return value? So these are the two things we want to focus on. Let me now switch to the iPad and let's now talk about this example here. Okay. And again, you can see we got our student class. We got our student management system class, and also we got the single array SS, right? So this one here. And it's what we said is a polymorphic array. That's something we explained earlier, right? And you can definitely see its visualization over here, but we'll speak about it in a moment. So this is a polymorphic array. Polymorphic collection or array. Okay, and then the method that we are newly introducing is this method over here. Okay, so this is the method. Let me just box it. This method over here. Okay, this method getStudents. And I want you to pay attention to the return type right away over here. Whenever we have a particular return type, so what does this return type really mean? Okay, so this over here, the students over here, well, can be any other reference type, but for this one here, I want you to know the principle. So this one over here, let me write it down here. So this is the static type of return value from this accessor method, right? It returns something, so that's why it's an accessor. Okay, and we're talking about static type over here. But what about dynamically? Dynamically, the dynamic type that's actually of the return value can be any of the descending classes of the static type. That's the consequence. Okay. Dynamic type of the return value can be any descendant class of the static type. That's also very important to note. Okay, so dynamic type of the return value can be any descendant class of the static type over here. All right, that's a principle I want you to know right away, and then we'll see exactly how to exemplify that. Let's look at the definition for this method here. What we do is we simply say students s, initially simply null. Eventually, we want to return s over here. Okay, I want you to see this right away over here. You can see we are trying to return s over here. Okay. We want to judge to see whether or not this particular return statement is valid or not. Is this valid? In order to see that, we want to ask the following question. Can the expression, can the static type of this expression, which is just single variable, can the static type of S fulfill the expectation of the static type of the return value for this method? Indeed, it can. Okay, let me write down the question. Can the static type of S fulfill the static type of get students return value? Get students, I would say RT for return value, or RV, sorry, for return value. That's the critical question to ask. Can the static type of S fulfill the expectation of? Sorry, I missed the expectation of. Fulfill the expectations of. Okay. Fulfill the expectation of the static type of get students return value. Okay. Let's now see, can it? Indeed, it can, because you can see for S, its static type is declared to be students. Let me put it here. So I still want to explain other lines. So I don't want to mess it up. So this S, the static type is declared to be students. And can the students class fulfill the expectation for the return type? Students, indeed, because students is simply a descending class of itself. So that's okay, right? It's a very important principle for you to know. So this question over here is really the one for you to determine whether or not the return statement is actually valid. Be careful over here, okay? And number 2, let's now take a look at this particular line. And then before we go to the example code, let's look at this line here. Is this particular substitution valid? Well, it's I'm sure you know how to answer that, because whether or not this is valid depends on whether or not the static type for SSI. SS is a students array, and we talk about at a particular index, so the static type should be students, right? So this expression over here is of static type students. So what about S? S was declared of static type students. S over here is also static type. Okay, let me just link directly to the students so you will know. So now the question is, can students fulfill the expectation for students? Indeed. So that's why this part over here, the expectation is valid. Let me recap very quickly before I move on, right? What I just spoke about were 2 things, okay? You want to know how to determine, number 1, whether or not the return statements for an excessive method is actually valid. The way to do it is to see what expression you're returning. The expression I'm returning here, I want to check to see whether its static type can fulfill the expectation of the return type of the method. That's what I did, right? Number 1. Okay, that's number 1. That's really important. That's number 1. And number 2 is what I said over here. Okay, so number 2 is this particular substitution, which I just explained. Over here, when I try to do this substitution here, whether that would be valid or not is, I want to check to see the static type for the right-hand side, as usual. Would it fulfill the expectation for the left-hand side, right? This one here, number 2 is not really new. But for number 1, this is new, but following the same principle. Okay. Having said this, let's now take a look at the example code, which is not too bad, right? It looks a little bit long, but the idea is really logical over here. And for the first part of the code, I'm just going to tell you what it is supposed to do, and then skip it, because we already spoke about how it's detailed tracing in the earlier video. So this part over here, starting from here all the way to over here, these are the steps for you to build the polymorphic array. Okay, so here this is really for building the polymorphic array. Polymorphic array at the runtime. You can see we are trying to create different objects of different dynamic type over here, and also we are adding them into the student management system, like this line over here. Oh, I can do better. This line over here. Oops. Okay, let me just do once more. This one, and also this one here, right? You can see 1, 2, 3, 4. So these 4 lines we explained in detail in the earlier part of the module. So these are for you to build the polymorphic array. And I want to focus on what happens after. Okay. Polymorphic array over here. Okay. Let me just try to go thicker over here. Polymorphic array is a very important term to always emphasize. Let's now talk about what if we want to call some methods on the student management system. What's going to happen? Let's go one by one. If I say SMS dot get students at index 0, okay, and we want to assign the return value into S. So we want to ask first of all whether or not this substitution is actually valid, right? I'll do this one for you, and then there's another one that happens later. You can see there's another one, which is S is assigned to SMS.getStudents over here. Let me just try the box in the same way. So this is just another one, but the only difference is we are trying to say 1 rather than 0. But the argument should be similar. So I'll do the argument for 1. I'll let you argue the other one as an exercise over here. Okay. So now we want to argue to see whether or not this is valid. Okay, is it valid? The answer is it is. Because always follow the same principle. The static type for the right-hand side must be able to fulfill the static type of the left-hand side, its expectation. What's the static type for the left-hand side? Here, you want to see that the static type really depends on how you declare the get students method. It is declared as for return type students. Right? Static type will be the return type of get students. Okay, which is students in this case. All right. So this part over here, as I said, over here underneath of the line, the return type will just be students. Can students fulfill the expectation of students? Indeed, it can. All right, because the return type can fulfill the expectations of the static type of S. Static type of S. Okay, much information over here, but hopefully you're still under control. All right, let's now talk about some tracing over here. Let's try instance of. So I'm trying instance of over here, and also instance of over here, right? You can see on the left, I simply use the variable S. What's really S? So we are doing this SMS.getStudents0. Let's now try to trace this code very quickly, right? So now I would just be 0. And then it's actually not invalid. So that's why this part here is not going to be executed. So we're just going to execute this part over here. So we're going to return S. S will simply just be assigned SS at index. In this case, it will be 0. So what's SS at index 0? SS at index 0 is pointing to this particular object over here. So that's why it's going to be this. S is pointing to this object over here. So that means dynamic type for S will be resident students. Okay, you really want to study the structure of the code over here and to see how I combine things together. It's actually quite important. So the dynamic type will just be resident students. All right, so the question really is, can the dynamic type of S, which is resident students, fulfill the expectation of students? Indeed, it can, right? And also, can the dynamic type of students, can the dynamic type of S, which is resident students, fulfill resident students? It also can. So that's why it's going to be true. So the whole thing over here is going to be true. Right? I say green, so that's because it's true. What about the second one? What if I say over here, S instance of non-resident students? Should it be true or false? It should be false because dynamic type of S currently is actually resident students because it's pointing to some resident student objects. Can it fulfill non-resident students? No, it cannot, because this resident student is not a descending class of non-resident student. If you recall the hierarchy, right, we have seen that many times, but just in case you need it. So remember, this is a hierarchy. Students, underneath we got resident students, and also we got non-resident students over here, right? You can see dynamic type over here is actually resident students. And can it fulfill non-resident students? Can resident student fulfill non-resident student? No, it cannot, because this is not a descending class of this. That's why it's going to be false. Right? It's going to be false, so I'm just going to highlight it in red over here. So that's false. Okay. Oh, let me do slightly better. Okay. So it's going to be false. It's difficult to actually highlight exactly that line. Okay, let me just do one more time. If not, I'll give up. Like that. All right, good. Okay, let's now go on. And let's now see another example for dynamic binding. So if we try s.getTuition over here, depending on what this dynamic type for s is, dynamic binding is going to make sure the correct version, the corresponding version of getTuition is going to be called. Because you see S is currently pointing to dynamic type resident students. So that means we're going to apply the version of the version of the getTuition method in the resident student class, which will make use of premium rates. So that's what you will see over here. Right? It's really important to know that. So here you're just going to remind yourself the dynamic type of S at this point is resident students. Okay. Let's now take a look at one assignment over here that follows. Okay, can we take a look at this line here? This line over here. So you can see that. So we want to argue whether or not this substitution is actually valid or not. Can you pause the video and tell me whether or not it's valid and give me the justification? All right, assuming that you thought about it. So this is how we reason. This part here, the right hand side, what's its static type? It is, it's a static type simply correspond to this the return type for get students. So that would be students. And just to remind you, it's the return type, RT. Okay, can it fulfill the expectation of resident student on this side over here? No, it cannot. So that's why this one over here is actually invalid. So that's why this substitution over here is actually not valid. Right? That's why you'll see here. All right, that's a very important thing for you to see. Whenever you have the right-hand side being some method call to some accessor, in that case, you want to see statically what's the return type for the accessor. That's so important. All right, the rest of the code is going to be very similar. So let me just tell you, and then I can give the rest to you as an exercise. So here we are saying we are doing some reassignment to S. So what we're doing is sms.getStudents at index 1. So when we do that, we are still executing this method here. And when we get to this part here, we are saying S, the return value is reassigned to SS at index 1, since we're passing argument 1. So now index 1 is going to be pointing to this array. So that means S, rather than, let me just say this, S rather than pointing to this, this resident student object here, it is now going to point to, let me just try to see, it's going to point to, okay, there's no way around. I have to cross the line, but let me do it this way. It's going to point to this non-resident student object instead. So that means when you want to trace all the lines over here, you have to know that S right now, its dynamic type has become non-resident students. So that means at this point, dynamic type of S has just become non-resident students. So when you try to reason about instance of and also which version of the getTuition will be called, it should be corresponding to the dynamic type that has just been changed, right? Because we did some variable reassignments, the substitution. Remember, whenever you do some reference variable substitution, you also modify the dynamic type to whatever object that you newly is pointing to. Okay, and then we got another example over here where the assignment is simply not valid. You can also do the similar argument, right? Look at what's the static type of the right-hand side, which is students, and see whether or not you can fulfill the expectation for the static type over here. right? You will see the similar answer. Okay, so that's about the example I would like to go over with you about return type. Let's now go back. Of course, on the slide, it's very simple, just to tell you the principle. Of course, you want to really go over my walkthrough, and then to make sure you can also reproduce it, and especially for any justification about the substitution or about the reassignments. Okay, so that's the example code we just went over. And then this is like a summary, just to tell you the structure for the polymorphic array. It's so important for you to understand why it is so-called polymorphic array over here. All right, as I explained earlier. Okay, so that's about it. And the last part for the inheritance lecture would be to actually go over, to summarize the rules, and also to go over some more examples about the equals method and also the two-string method.